Okay, let's go ahead and get started. Today we are walking through testing, managing, and collaborating on Hexaly routing models using the Nextmv platform. I'm Renuka from Nextmv, and I will be your host for today. Our presenters are Ryan, co-founder and CTO at Nextmv, and Leah, senior optimization scientist at Hexaly. Today, we'll walk through quick introductions to both Nextmv and Hexaly, and then we will dive right into the platform to see these technologies in action together, where we'll be performing scenario tests and more. Leah will also walk us through the latest and greatest from Hexaly, including the Hexaly Optimizer 14.5, which was recently released. We'll save time at the end for Q&A, but we do have Nextmovers on the call, so please feel free to ask questions during the session, and my teammates are happy to answer live via the chat or using the Q&A feature in Zoom. Just ensure when you're using the chat to toggle between host and panelists and everyone, depending on who you'd like to see your message. So with that, let's dive right in. So what is Nextmv? Nextmv is a decision ops platform that acts as the speed, trust, and innovation layers for your decisions. And these are built with observability, experimentation, orchestration, and collaboration, all of which you'll see today. And we integrate with popular modeling tools and solvers that you're likely familiar with. Of course, we'll be exploring what it looks like to use Hexaly today on the platform. And we mentioned transparency. Too often we hear that business teams and stakeholders don't feel like they know what the algorithm is actually doing, and that can result in a lack of trust. So sometimes it feels like a bit of a black box. So at Nextmv, we use a decision intelligence platform approach to make the model and the outcomes more accessible. And we do this using a common user interface, a testing framework, and configurable levers for tuning and testing. And this really leads to more transparent decisions and better outcomes overall for the business. And of course, our platform was built with collaboration in mind. So as we'll see today in Ryan's speedrun, we know that there are multiple team members and roles that make up the operations function, and they really need to be able to focus on their specific responsibilities. So for instance, modelers can focus on modeling. They don't really have to worry about building and maintaining all of the tooling and infrastructure around it. Similarly, software engineers can easily integrate those models into existing systems. And business users and operators can interact with the UI to explore what-if scenarios with testing, and then easily share results with stakeholders using deep links within the platform. So as I mentioned today, we'll be covering using Hexaly with Nextmv. So I want to hand it over to Leah to give us a quick introduction to the Hexaly Optimizer.
Hi, everyone. So Hexaly Optimizer is a hybrid mathematical optimization solver. It's both hybrid regarding the modeling part and the solving part. So Hexaly was first developed with real-world industrial problems in mind. And for that, we needed a high-level modeling formalism for industrial problems. That means that it had to be generic to capture industrial problems and their business constraints, because these constraints can be sometimes a little bit unusual and quite different from those you encounter in academic optimization problems. And the modeling also had to be sparse to be able to handle large-scale instances, because in the industry, you generally have very large instances that you want to be able to solve in rather short running times. And so to be able to do that, we developed a set-based modeling formalism that both hybridizes and extends MINLP and CP formalisms. So it's got a lot of nonlinear expressions. That's the regular MINLP part. But the real Hexaly specific things are the sets, lists, and interval decisions. So these are decisions in the same way that booleans, integers, or floats are decisions for other commercial solvers. So it's really the same idea, except the difference is that their value are not just one number, but a collection of numbers. And these decisions are really very practical because they enable you to write compact models that are much more natural than MIP-like models. And then to interact with these decisions, of course, we have a lot of set-based operators that enable you to write your models, but you also have lambda functions. And these lambda functions are really interesting because they enable you to compute sums, products, minimum, maximums, and so on a variable number of terms. And that is really one of the strengths of Hexaly Optimizer's modeling formalism. Now for the solving part, Hexaly is also a hybrid solver there because under the hood, you will find a lot of very different exact and heuristic methods, like classic techniques from many different areas of optimization, like MIP, MINLP, constraint programming, heuristics, and so on. So you have a few examples there. I don't think it's worth listing them all. Yeah, the only important thing here to have in mind is that these are very classic techniques from the literature that we implemented and hybridized together to make one solver with all of that inside. And so, yeah, you don't have to choose which of these techniques will apply. It's all automatic. No parameterization is needed. It just automatically launches everything that's relevant for your model. And thanks to that, our compact and set-based modeling formalism and our exact and heuristic methods under the hood, all of that together makes Hexaly a very fast and scalable solver for a lot of different industrial problems, mostly like in routing, order picking, scheduling, sequencing, packing, and many more domains. Yes.
Wonderful. Thank you, Leah, for that wonderful introduction to Hexaly. So now that we've gotten an introduction to both Hexaly and Nextmv, let's see them in action together. So Ryan, can you tell me a little bit about the model that we're using today?
Yeah, so today we're going to be showing an example of what's called the prize collecting vehicle routing problem. This is something that we took from Hexaly's website, and essentially we did sort of two things to it. We wired it up to Nextmv infrastructure, and we'll look at what some of that code looks like briefly at the end. And then we sort of added enough to the model to make it operationally realistic, so we can look at what some various scenarios might look like in a real world environment. The basic problem here is that we have a set of requests that we're trying to service, which require different amounts of goods, and we have a fleet with small, medium, and large vehicles, with each having a different kind of capacity and fixed and marginal costs per distance. And we're trying to organize tomorrow's deliveries such that we minimize or maximize various measures, and those could be things like distance or total cost or the amount of pay that drivers get. In advance, we know things like the prizes, which are essentially tips or delivery fees. And we have the option to not service requests, but that could be expensive to us for one reason or another. And, in terms of actually to telling the optimizer, telling Hexaly what we want to solve for, there's lots of different options. And this is where it becomes somewhat realistic, really is, we could try to optimize for number of vehicles used first, or minimizing unserviced requests. We also care about things like balancing driver pay or cost per mile, et cetera, et cetera. So that's the model that we'll be showing.
Great. So let's dive into a real world scenario here, and where this model is powering our fleet planning operations in production. So we'll do a little role play scenario where Ryan is one of the decision scientists on the team, and I will represent a teammate on the operations side who has a few questions about planning for tomorrow, as well as the upcoming months with some spikes in orders. So
Excellent.
Ryan, as you pulled this up, do you mind doing a quick overview of just kind of what our Hexaly model looks like on Nextmv?
Yeah, and can you see my screen right now?
Yes, looks
Okay,
great.
great. All right, so what we're looking at right now is the Nextmv Cloud Console, and this is the application wrapper for our model. So you can see here it has a latest published executable, so that's essentially the artifact and everything that's necessary to run this model. It tells me when that was created, and so on and so forth. I have a little chart showing me, how things have been changing over time with respect to runs on the model. For instance, I can change this to total cost, and we can see that over time, our total estimated cost for operating has been going up within the model, and so on and so forth. I can see over here I have runs. So these are production runs or development runs that have been recorded. And I can click into them. So if we go into this one, this is a run where we had 10 small vehicles, 15 medium vehicles, and 20 large vehicles. And we can see that the output of this run, we had 74 unserviced requests, and we used 45 vehicles. I also have some visual assets that go with this, which have been added to the model. For instance, I can see this histogram or this bar chart of vehicles used versus available, and I can see we're using the entire fleet. I could look at the histogram of driver payments. So these are tips that are paid to numbers of drivers from the solution, and I can see things like the actual routes that were planned. So here we can see these are all the routes planned. If I zoom in a bit, I'll see some unserviced ones like this one that's in the middle of the Schuylkill River. And so those 74 unserviced requests would be the gray things. And then finally, I have a histogram of distances that are driven by the various drivers in the fleet, according to this plan.
Perfect. I think this is a great place for me to dive in with my first question. So we have our orders confirmed for tomorrow. Given that number of orders, I think we have around 550 that have come in. I'm wondering if our current fleet size is going to be able to cover all of the deliveries. So, like you said, we have 10 small, 15 medium, and 20 large vehicles. Are we going to see quite a few number of unserviced stops with that fleet
Yeah.
composition?
So with this one, we saw about 74. If you want, we could increase that number on the vehicles and activate more of them
Yeah,
and see what happens.
let's try that.
Okay, so what I'm going to do is I'm just going to clone this existing run. So we'll start with the same configuration and use the same input. And so that's all set up for me. Raina, what do you want to increase the numbers to?
Let's increase each by 5. Let's start there.
Okay, so we'll go from 10 to 15 small, 15 to 20 medium, and 20 to 25 large. Okay, I'll start that run. All right, now it's in the platform and it's queued and it'll be done in probably about 30 seconds or so. While that's happening, I'm just going to pull up one we did. See, here it is in a queued state right before the tech talk, where it shows the actual output of this. So here is that same configuration with 15, 20, 25 vehicles. And you can see here we have no unserviced requests.
Okay,
if I
great.
go into the vehicles used chart, I can see that it used all of the large vehicles, all of the medium, but 6 of the small vehicles were not used. So that looks like a fleet composition that would service all of our requests.
Okay, great. And do you mind, is there a way I can see these tables side by side to share with our
Yes,
planners?
absolutely. So if I go here, I can select both and I can click compare runs. And that will give me a view where all of the metrics are listed right next to each other, so I can see the total cost. So from one configuration to the other, the smaller fleet is on the left over here, and the larger fleet is on the right. I can see things like the result value, how many, total tips, vehicles in use, etc. And I can also take a look at those visual assets side by side. So this is the fleet usage, and I can look at things like, oops, that's the wrong thing. Here we go, the routes maps and so on and so forth.
Perfect. Okay. I will share this with our scheduling team and make sure we use that updated fleet size for tomorrow. Great. Okay, so now we have that sorted. I am a little worried about the upcoming holiday week. I know that last year it was a bit of a challenge. We had such a high volume of orders. Is the fleet composition we just updated to, do you think that's going to hold up through the holiday week that's coming up? I'd love to see a breakdown by day if that's possible.
Yeah, sure. So what we did to answer that question going forward is we created this Philly high volume input set. So if I click on that, These are the high volume days that we recorded from history. And so it's fairly easy for us to take that configuration and run it against each of these historical volume days and see what would have happened. So what we can do is go into what we call a scenario test. And so I'm going to take this scenario test and I'm going to clone it. So this is again with 10, 15, and 20 vehicles. And I'm going to change that to 15, 20, 25, test. And we'll use it with that Philly high volume input set. And now what I'm going to do is again update the fleet composition. And if I wanted, I could add more configuration options here too, like I could use a different objective function or different solve durations and so on and so forth. In this case, we're just updating the fleet composition and seeing what would happen. And then I can review the runs. So this will kick off 7 runs on the platform, and I'll create that scenario test and run it. While that's going on, I'm going to pull out this one from the oven, which we ran right before the tech talk. And these are the results that we're going to get back from that scenario test. What view do you have in mind here, Renu?
Yeah, I'm wondering. So I'm interested in seeing the number of unserviced stops per day of that high volume week, if that's possible to do here.
Yep. Let me change this to a heat map table because I think that'll be the easiest thing to look at. And I'm going to pull all of these metrics, the default metrics, off here. And we can just look at it by the input directly. And so this is, whoops, the wrong thing. I should be looking at the unserviced requests. There we go. All right, so now we have unserviced requests by day for that historical volume.
Got it. Okay, so it looks like Friday is going to be our toughest day, so definitely want to make sure that we have enough vehicles and drivers scheduled to handle that.
Yeah, Randy, do you want me to send the link for this over to you?
That would be really helpful.
Okay, I'll just click on this, share view, and then put that into Slack. You should hear the Slack notification any second now.
Thank you. Okay, I will share that. That makes me feel better about planning for that holiday week upcoming. And we did meet with stakeholders recently who were just wanting to explore scenarios that reduce total cost overall. I realize this might mean switching the model objectives.
Yep.
Is that something that we can explore easily in terms of just looking at how we can reduce total cost overall with our current fleet composition?
Yeah, we've been experimenting with that with a thing we call ensemble definitions in the platform.
Okay.
And so we have this ensemble definition, which I'll bring up on a run. But basically what it allows us to do is specify a number of different configurations for the solver and then choose an output, the best output that it gives us. So let me pull up one of these ensemble runs that we've done. This one should work nicely. And so what you can see here, I'll clone it and we can look at what creating this looks like, is we have different sort of names for the ordering of the objectives, right? And so in this one, we're trying to minimize cost and then maximize the driver pay. In this one, we're trying to also minimize number of vehicles used. And this one, we're also trying to consider distance, right? And so there's different orderings to these objectives. And this is something where Hexaly is really nice in that it gives us this very easy multi-objective interface and we can reorder these and see what happens. And so what we're doing here is we have that same fleet composition across all these different configurations, but we're just changing the objective function. And at the end of that, we're just going to choose the one that gives us the lowest cost. And so we're trying to sort of meet different service levels or criteria for drivers or so on and so forth. And at the end of the day, we just sort of say, okay, any one of these could be acceptable. Let's choose the lowest cost one going forward. Or we could use some other metric or something more complex here. So that's how we would start the run. If I go back to that one, we can look at the output. And this is what the ensemble output actually looks like. You can see we have these 3 different runs here, and it chose this one as its best. And so that's the solution that it actually returns to us. So this gives us a way of always controlling for one thing across different either scenarios or configurations.
Wonderful. So then this, just to summarize from my understanding, the rule that we've set here is reducing our total cost, and then we were able to create different run groups with the custom objectives that you walked through
Yep.
in the ensemble definition. Okay, yep, I think that's exactly what they're looking for. Okay, I will share this with them as well because I know they're meeting on this again this week. And I know you have to run, Ryan, to another meeting. I have one final question for you. I did hear from the team that we might be able to get some additional vehicles, but they have different capacities than what we had initially planned for when we set up this model. Is that something that's going to be a big challenge to update for this model for us to be able to maybe compare this model to one with vehicles of different capacities?
Yeah, not at all. So as you remember, when we were doing the MVP of this, I kind of hard coded the capacities. We've actually never really changed that.
Mhm.
But if we want to add something to that or expose that as an option, it's actually pretty easy in the platform. So this is the model code itself. If I click into here, you can see it's really just, it's a Hexaly solver with sort of Nextmv scaffolding around it. So this looks like the Hexaly model that you'd expect it to. And then the scaffolding is all in this main here. And so we have Nextmv options hooked up here, which map both locally on my dev environment, but also in cloud to those UI controls that we had.
Okay.
So just for example, we could add, another line to these, or I could just say, for example, change this capacity from 2000 to 2500 or something and push a new version for you. So let's just do that real quick to see what something like that looks like. So I've changed it locally. And if I now want to push that model up to you, I'm just going to do a Nextmv Cloud app push, and I'm going to give it the app name or app ID. And now what it's doing is it's bundling up the dependencies and so on and so forth. So for example, if I say like upgraded to the latest version of Hexaly, that would now be accounted for. Sort of any code or dependency changes that are important just are automatically bundled up for you. And we can see in a second, it's going to start pushing it up to the cloud application. Okay. It's pushed it, and now it's saying, do you want to create a new version? So I'm going to say yes. And it's going to give me a new version ID. And it's saying, do I want to link it to an instance? And at this point, I could put capacity test or something like that as the instance ID. And it'll ask me if it wants to create it. So now we have a Nextmv endpoint, which I can show in here. Let's refresh this. And we have this capacity test. And so you can make requests directly to that, or you could use it in scenario tests without affecting production.
Oh, that's great. That was a lot faster than I was expecting. Okay, so now that's already in the console, so we're able to go in and start performing tests right away using that updated capacity.
Go nuts.
Wonderful. All right, well, thanks for your time, Ryan. I know you have to jump to another call, and I will let the stakeholders see all of those links you shared with me.
That was fun. Thanks, Raina.
All right. So what did we just see happen? Again, Ryan was playing the part of the decision scientist, and I was playing the role of someone on more of like the business user operator side of the house. And we ran through a few scenarios pretty quickly. The first is looking at vehicle composition and fleet composition and size to ensure that we are servicing all of our stops. So we were able to compare runs using a different fleet composition. We were also able to look at a week in the past using an input file that we had saved from a week that had really large spikes in order volume for, let's say, a holiday like Mother's Day. And we were able to then customize that chart to look at each day and see which days would have the highest unserviced requests based on our current fleet composition. And we also looked at which objective combination lowers total cost. So again, this is where we set a rule and then created different run groups with different options And then the platform actually chose the best run for us to use moving forward. So I want to, again, really thank Leah for sharing an introduction to Hexaly, and I want to talk a little bit about what's new at Hexaly. And keep in mind, I believe Ryan did use the new Hexaly Optimizer 14.5 for the speed run. So tell us a little bit more about what's new and what you're excited about.
Sure. Well, as you said, we recently released a new version. And with that new version comes a lot of improvements. I just put the, let's say, 3 main categories of improvements here on the slide. So the first one would be improvements on price collecting, both routing and scheduling problems, like, for example, the one Ryan showed us with the demo. Then we also have a lot of improvements on industrial instances in general, so in fields like routing, scheduling, packing, many more. But yeah, the important thing here is that they're really industrial, real-world problems with business constraints. Like, for example, multi-trip routing problems or scheduling problems with particular calendar constraints, packing problem with conflicts, and many other examples. And the last point is that we also have a lot of improvements on nonlinear optimization in general, thanks to improvements on our interior points algorithm.
Wonderful. Thank you for sharing those updates. I know you work directly on the optimizer itself, so it's great to hear from you. Okay, so we have a little bit of time for Q&A. I'll stop sharing here. And I think, let's see, this one ties pretty closely into what you were just mentioning with routing. So what makes Hexaly a good fit for routing, Leah?
Yeah, Hexaly is really an excellent fit for routing problems because of many, many things. The first one is the modeling formalism. Like our list-based modeling formalism, is really perfectly suited for large-scale industrial routing problems. Thanks to the lists, the operators, the lambda functions, we are able to build very compact models, much more natural and easier to write than MIP models. And they're also very generic, thanks to our generic operators. And thanks to that, we can capture basically every business constraint that you might think of. So yeah, being able to write your problem is already a good point. And then thanks to these compact models and the primal heuristics that were implemented inside the solver, we are able to find excellent quality solutions very quickly. Like a good recent example for that would be a recent challenge from the CVRP lib. It's called the CVRP lib Best Known Solution Challenge. So they built new instances of the capacitated vehicle routing problem with between 1,000 and 10,000 points. And on that benchmark, we reached 2.6% from the best known solution in 60 seconds. And considering that the best known solution was obtained with a dedicated solver with virtually unlimited time, I'd say 2.6% is quite a good score. And last point, we also have generic and dedicated reformulations of routing problems to be able to compute bounds even on these list-based models.
Great. And can you tell me a little bit more about one, how Hexaly computes bounds on these list-based routing models, and also kind of like the types of business constraints for routing problems that Hexaly handles well?
Yeah, sure. Depending on the size of the model, like whether the instance is very small and easy to solve or harder to solve because it's large, we either have classic generic MIP reformulations or automatic column generation and branch cut and price, or for harder instances, we switch to column elimination. And regarding business constraints, you can find a lot of examples on our website, like, for example, pickup and delivery constraints, backhauls, dial and write problems. We can also handle multiple depots and multiple trips, time windows, time-dependent travel times, driver breaks and regulations in general, split delivery as well, transshipment facilities, pre-assignments, incompatibilities, and the list could go on and on.
Yeah, and it's great to see, Ryan in this speed run being able to really like tinker with each of those and see how that impacts the solution. So that makes it a really nice fit. So that leads us into our last question. I know we're at time here, but I'll squeeze this one in. From your perspective, Leah, and playing around with Nextmv, what do you think is the biggest pain point that Nextmv solves for Hexaly users?
Well, Hexaly is a great solver, but it's just that. It's just a solver. So if you use it alone, you write a model, then you see the logs in the console when you run it, and that's it. So anything else you might need on top of that to analyze your solutions, compare them, anything, you just have to rebuild everything from scratch. Yeah, if you are using Hexaly through Nextmv instead of using it alone, then it's much more user-friendly because, as Ryan showed us with the demo, you can then build scenarios, compare them, choose like a meta objective function to decide which scenario is the best, and so on. So yeah, I'd say it's much more user-friendly.
Great. Well, thank you both for joining us today and presenting. We really appreciate your time. And I want to thank everybody who joined us as well and asked questions. I think we are a little bit over, so I'll wrap it up for today. If we didn't get to your question, not to worry, we will make sure to answer via email. And again, just want to say thank you everybody for joining us, and we will see you on the next one.